Today we're going to study access modifiers. So far you have only seen one access modifier, which is public. You could notice it in method main or creating any class. They contain this access modifier right from the start. There are four access modifiers: public, private, protected, and default. Let's take a look at public and private. Open the code and create class man. Create its fields, name and age, and specify public access modifier. To do so, write public, string name, and public int age. Let's create a constructor for assigning values to the fields. Don't forget about the fast way of creating a constructor by pressing Alt-Insert. Select the constructor and the fields we would like to be initialized. Holding Ctrl, select the fields and click OK. Now let's create a method which will print out information about a man on the console. This method will also be public. It will not return anything, so write void. Call this method showInfo. No parameters are needed. We'll simply print out name and age. Let's insert a space character here for convenience. Open method main, delete all the code and create a new man. Let it be Ivan, 27 years old. Call method showInfo. And you can see name Ivan, age 27. Now let's imagine a situation when somebody, after creating the object man, writes man.age, assign symbol, and -40. When you run the project, you can see name Ivan, age -40. So Ivan is now -40 years old, which is nonsense. We must not have negative values here. It happens so because we have granted access to the fields of object man. Anybody using this object can assign absolutely all kinds of values to its fields. Actually, giving access to fields is a very bad practice. It's called breakdown of encapsulation. I will focus on this issue further on. Let's get back to class main and change the access modifier for the fields from public to private. When we get back to main, we can see an error. If we write the name of the variable and use the dot operator, we will not see our fields. We have just restricted access to them. Nobody will be able to assign values to our fields. Public access modifier grants access to the element next to which it is specified. If it's a public variable, this variable can be accessed. If it's a method, it can be accessed from any part of the code. Wherever you create this object, if it's declared as public, you will have access to it. For example, we can see method showInfo now. Private access modifier is the polar opposite to it. Everything declared as private can only be accessed from within the class. It means that from man, we can still address these fields, assign them values, and retrieve them. It's possible provided that we are within the class where the variables were declared. But what should we do if Ivan has just had his birthday and we have to change his age to 28? For assigning values to restricted fields, the fields with private access modifier, setter methods are used. Simply defined, a setter is an ordinary method declared as public, which accepts as a parameter some value which we would like to set. Create a new method. Declare it public. It will not return values, so write void. Setters are usually called set and the variable name. In this case, we will set age, so let's call this method setAge. It will accept as a parameter the age which we wish to set. Type int age. In this method, we will use our instance variable this.age to assign the value of age. What is special about setters is that prior to setting, we can check what kind of value the user intends to enter. Let's arrange a conditional test. If age exceeds 0, the value will be accepted. Otherwise, the following message will be displayed. The age must be greater than 0. Open method main. Let our Ivan's age be set to 28. Type dot, set age and pass 28. Run the program and you can see that now Ivan is 28 years old. Let's now set his age to minus 40 years old. Run the program and you can see the age must be greater than 0 and the parameters of our man name Ivan age 27. Thus, we allowed setting values to the fields of our man, but at the same time, the data are checked for consistency. Let's say that we want to calculate the average age of several people. What should we do? We have no access to the fields. Method info prints out a single line. How can we retrieve Ivan's age? To retrieve the value of a field, getter methods are used. They're actually ordinary public methods without parameters which return the value of a field. Let's create a getter for age. Write public. It will return int type. Because variable age is of int type, call it getAge. It will not accept parameters. This method will return the instance variable age. Let's now within method main print out Ivan's age, but not the rest of the information about him. Type man.getAge. Let's print this out on the console. We will not create separate variables. We will simply pass the age of our man as a parameter to println method. Run the program. You can see 27 years old. Thus, we have restricted access to object man. There are cases when read-only access must be granted, so that the user could retrieve data but not change them. In this case, we'll declare our variable private and create a getter for it. For example, let's set the string getter to name, public string getName, and we'll return name. In this case, it's impossible to assign the value of variable name from any other code. But this value can be retrieved, so we have created a variable which has only read access granted. Since getters and setters are very often used, IntelliJ IDEA features a way of setting them faster. Let's delete these methods. This is done exactly the same way the constructors are created. Press Alt-Insert and select what you need to create a getter, a setter, or both. Let's create a getter for each of the fields for both name and age. Hold Ctrl, select a menu item and click OK. So we have created two methods, getName, which returns a string, and getAge, which returns an int. Now let's digress a little to discuss encapsulation. Here's a real-world example. Imagine a car. You're driving in a steady rhythm. And when you need to accelerate, you find and pull the engine throttle cable to increase the fuel feed, and you pump more air so the car accelerates. It's not so comfortable, is it? It could be way easier with the gas pedal to push and not bother about how the acceleration is accomplished. We can't care less about the throttle cable, carburetor, or any other hardware. All we need to think about is the pedal, the method we interact with, everything under the hood. We don't even have to think how it all works. And here is another example, an ATM. What if an ATM were a kind of a closet and anybody would be able to take so much money as they needed and go away, and those others who would like to deposit money would place their money into this closet and go away. The same happens when we grant access to all the data of our class in the hope that the users will not abuse or misuse them. For such cases, both the ATM and the car feature interfaces. The users can clearly see how they can use the object and what for. And the car, the user has a steering wheel, pedals, and a gearbox. These are pretty small things, but they can be used to control all the process without a deep knowledge of how they work. The ATM has buttons, sensors, a bank card slot, so if you have funds on your account, the ATM will dispense them to you. If not, it will not. And how it works, nobody cares, nobody at all. So encapsulation is hiding the mechanism. We create a class, doing it whatever we need and however we need, but we grant access only to those methods which the users will need. So what is the modifier and how is it used? There is a good rule. All fields must be private. Anything at all that can be private must be private. Access to fields is to grant it only through mutator methods, getters and setters. We still have two more access modifiers to discuss, protected and default. I will not cover protected today because before that, you need to get to know another topic. But today we can study default. Right-click on SRC, select New, and now select not a class, but a package. Let's call it box with a lowercase letter. Click the arrow to see our package. Here we can see it. All the code in Java is usually stored in packages. You can think of them as of ordinary folders on your PC. Packages are usually the same. Classes are not usually stored this way, simply in folder SRC without being contained in packages. If several classes differ in their logic, for example, some are responsible for the visual appearance, others for data storage, the third ones for the logic. It's customary to store all classes intended for one purpose in a separate package. Let's create two more packages. We'll call one of them main, and it will be for storing our class main. Package box will be for everything concerning boxes. Package test is for the test classes which are for trying out something new. Let's move all the classes to where they belong. Class box will be moved to package box. Just drag and drop it and click refactor here. Do the same with class main. Man and test are for testing new features, so let's move them both to package test. Now when you open any class, you'll see a new word package. It simply indicates which package contains this class. If you open class main, you will see an error. Our class is trying to use object man, which is located in a different package. As you remember, class man is in package test. In order to use a class from another package, the following construction is used. Import, then the name of the package, which is test in our case, then a dot operator, and the class which we want to use. We'll use class man, semicolon. Now the error is resolved. Normally, IDEA performs import operations automatically. It hardly ever occurs that you have to manually write such constructions. Let's delete this line. Now we can see an error. Click it and press Alt-Enter. Select menu item Import Class, and this line is added automatically. Let's see what else we've got in package test. Here is class test. Let's create it. Type test. And now if you press tab, this class will be imported automatically. Now we can use it. Let's delete it. Unused imports are highlighted in gray. It's best to delete them. So why have we learned how to use packages? Take a look at class box. It's not stated here either private or public. There is no access modifier whatsoever. The same is true for the constructors and methods. So if it's not stated, modifier default is used. It's a default access modifier. It grants full access within its package. It means that if we use it in one package, it will work as if it's public. And if we try to use it in a different package, it will function as private. Let's create a new box in class main. You can see a box imported from a different package. And we encounter an error. Box is not public. If we go to class box, we'll see that absolutely all our constructors have no access modifier specified, so their access modifier is default, and we cannot access these constructors, the fields or methods from another package. I wouldn't recommend using default modifiers without having to. You'd better use either private or public, following the rule I have told you about. All fields must be private, and everything that can be private must be private. Use public only where private is impossible. Your homework assignment will be to modify class box so that correct access modifiers are used everywhere. None of the fields must be public. If you need access to fields somewhere, create getters or setters or both. Good luck! See you in our next lesson.